Welcome everyone to BTT 151, Fundamentals of Electricity. My name is Steve Vidal and I will be your online instructor this semester. Please review the syllabus that is uploaded in D2L. The text that we're going to be using is called Electrical Studies for Trades by Stephen L. Herman. So whether you have the physical text or the online version, either one is fine. During the course of the semester, we're going to have 3 individual exams, plus a midterm exam and a final exam. And each week we're going to have graded homework assignments based on the material that we will study in each of the units of our textbook. What I like to do is do a small presentation just to introduce the topics we are going to study, and then please, of course, read the information in your textbook. There is a PowerPoint presentation that is going to accompany that material. Then a lot of times I will upload additional videos or demonstrations to help understand the material in each unit as we progress through the course. So our very first unit is called Unit 1 on Atomic Structures. So some definitions to keep in mind: an atom, the basic building block of the universe, or the smallest that we can break something down into. Matter, remember, is any physical substance that has mass and occupies space. Specifically, as we study atomic theory, we're going to be interested in 3 subatomic particles, one called the proton, which is positively charged, one called the neutron, which has a neutral or zero charge, and one called an electron that has a negative charge. Now, normally we represent an atom, and I always like to start with a hydrogen atom with my explanation, because hydrogen is the first element listed on the chemical periodic table, and the hydrogen atom is going to have 1 proton, 1 neutron, and 1 electron. So the center core of the atom we call the nucleus, and in the nucleus is where the protons and neutrons reside. In shells that orbit the nucleus, we have that negatively charged particle called an electron. Well, as electrical folks, we're going to be very interested in a specific type of an electron that's called a valence electron. And all valence means the valence shell is the furthest orbital away from the nucleus. And this becomes important because as we study some static electricity concepts in Unit 1, we're eventually going to gain an understanding of how electrons in motion become part of what's called current flow. Electrons in motion. So keep in mind, proton is positively charged, neutron has neutral or no charge, and the electron has a negative charge. Specific law in physics called the law of electrostatic attraction details the relationship between charged particles. So for example, like charges repel, unlike charges attract. So if I have 2 positively charged items, those would be like charges. That would be a force of repulsion. If I have a positively charged and a negatively charged item, subatomic particle, let's say, those charges would be unlike. That would be a force of attraction. So like charges repel, unlike charges attract. What we are also very interested in, the law of electrostatic attraction, is going to demonstrate that the further an electron is away from the nucleus, the more weakly bound or weakly held, or weakly attached, I should say, it is to the nucleus. So the further away the electron or electrons are, they can very easily be liberated to become part of current flow, electrons in motion. So some other definitions to keep in mind: conductors, insulators, and semiconductors. Well, the very easiest way to understand what a conductor is, a conductor simply conducts electricity very, very easily. Any metal is a good example of a conductor. And again, as electrical folks, what we would be concerned with, copper conductors, aluminum conductors, for example, they very, very easily conduct electricity. Whereas an insulator, just the opposite. An insulator does not conduct electricity very easily. Examples of insulators would be porcelain, basically any non-metal, porcelain, glass, leather. Any of these products do not conduct electricity very easily. So we have a conductor on one side that does conduct electricity very easily. We have an insulator on the other side of the spectrum that does not conduct electricity very easily. But right in the middle, we have another material called a semiconductor. And a semiconductor, very traditional semiconductor elements would be germanium and silicon. Elemental semiconductor materials behave like an insulator. But semiconductor materials, the kind of products you would find in your personal computer, in your laptop, in your phone, your iPhone, or your Android phone, for example, any electronic product made from a semiconductor material would exhibit these characteristics. So a semiconductor can be manufactured and designed to behave like a conductor, or like an insulator, or like anything in between. So please keep in mind the idea of how a conductor, a semiconductor, and an insulator relate to our study of atomic theory. Other definition I would like to call out is the atomic number that you would see represented in the periodic table. And the atomic number refers to the number of protons that would be contained within the nucleus of that specific atom. So please take a look at the information in Unit 1 on atomic structure. Plus I've uploaded a very good video from Khan Academy on atomic structure and atomic theory that will detail the relationship between protons, neutrons, and electrons. Additionally, you're going to find a homework assignment in Unit 1, so please do the Unit 1 assignment, and then that will automatically record that information and your score right to the gradebook in D2L. During the course of the semester, if you have any questions on any of the material, please feel free to email me anytime. I always try to get back in touch with folks in 24 hours or less. Additionally, what I like to do with online material is go over our graded homework assignments in a separate video session, plus our 3 exams and our midterm exam. We will cover those, go over the solution so that everyone has a very good understanding of the material. All right, so please have a very good week, and we will see you next week as we progress. Thank you.